Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. A very good evening or good morning to all of the students. Now we're going to proceed to the second chapter on under the topic of flow rate. Here, flow rate. Yeah. Basically, this topic is consists of a definition on the flow measurement. How we're going to quantify the fluid movement throughout the pipes or channel. The importance of critical for resource management, quality control and safety in industries, which is to me this is very important, and how it's going to be applied, how it's going to be manufactured, and the energy production here, environmental monitoring and so on and so forth. Okay, so this is the topic, and this is type of flow rate. As you know, flow rate is being quantified by a volumetric flow rate, which is Q, alright, where it measures volume passing a point per unit time, where the unit is meter cubic over second, or liter over minute, or liter over second, GPM, and etc. And of course, we're going to go for the mass flow rate as well, where it measures mass passing a point per unit time, where the unit in here basically we're going to deal with kilogram per second, pound per hour, and etc. So this is standard unit for flow rates. So basically for the flow, we got two type of flow. Firstly is a laminar flow, and then we go for turbulent flow. Alright, for the laminar flow is a smooth type flow, where it's a very well ordered layer. It goes with very low velocities, low mixing, and common in low viscosity fluid is a low flow rates, while in comparison or in contrast to the turbulent flow, it goes by a very kinetic motion. It got all those vortices, high velocity, significant mixing, campuran dia memang agak terkesan lah, dia campuran dia kan. Dan dia biasanya senang dijumpai di high viscosity fluid ataupun cecair yang mempunyai viscosity yang tinggi, ataupun biasa kita jumpa dengan proses yang memerlukan high flow rates lah. Okay. So ini ialah continuity equation, di mana secara prinsipnya mass entering equal mass existing for incompressible fluid. Formula dia ialah Q equivalent to AV. A ni ialah area, dan V ni ialah velocity. Okay, so dia akan kira lah flow rate tu macam mana. Okay, dan dia akan menerangkan lah how changing cross section area affect velocity dalam maintaining the flow rate. Maksudnya kalau kita kecilkan area, dia akan memberi kesan yang agak signifikan dalam kelajuan kita punya flow rate tu. Dalam kata lain, kalau kita kecilkan kita punya cross section area, kita akan dapat velocity yang tinggi. Kalau kita besarkan, kita dapat velocity yang rendah. Okay, so ni kita akan cerita pasal Bernoulli equation. Biasalah ni awak boleh cari dalam awak punya subjek yang awak pernah belajar sebelum ni, iaitu fluid dynamics. Ni formula dia lah, P plus 1 half rho V squared plus rho GH. Ni dia punya formula lah. Biasa tidak ada calculation pun dalam subjek kita ni. Di mana dia describe pressure, velocity and potential energy relationship in a flow. Alright. So untuk instrumen yang pertama, kita akan berkenalan dengan orifice plate. We going to deal with the orifice plates, where this type of measurement device they use flow rate. and they used to measure flow. They are used to measure the flow rate, and then they utilize the principle of pressure difference to determine the flow rate. Dia punya operating principle tu orifice plate ni is a thin plate lah kan, dia very nipis, and biasa dia precisely machine lah, ada lubang ataupun orifice, ada pembukaan dekat tengah-tengah. Jadi dengan ada inlet dengan outlet, inlet outlet, tengah tu ada orifice, maka kat situ awak dah boleh quantify berapa flow rate yang awak akan calculate. Jika area laluan tu, flow tu, area tu restricted, dia akan menyebabkan fluid punya velocity tu increase. Itu kita mengikut Bernoulli punya principle lah. As the velocity increase, the pressure decrease. Kalau velocity tu increase, pressure dia decrease. Okay. The pressure drop across the orifice is proportionate to the square of the area lah. Proportionate to the square of the area. So, inilah antara prinsip macam mana dia berfungsi. Pressure flow meter works, awak dapat tengok tu ada inlet, ada inlet dekat sini, dia lalu kat orifice yang ini, dan dia ada outlet. Okay, so area sini memberikan kesan, dia affects kepada satu, flow velocity, nombor 2 pressure. Alright, so saya teruskan lagi. Ini ialah measurement process. The pressure difference between the upstream and downstream sides of the orifice plate is measured using pressure sensor, and the pressure difference is correlated with the flow rate using established calibration curve or equation. Okay, the orifice plate's known geometry helps in calculating the actual flow rate. Okay, ni pula ialah venturimeters lah. Flow measuring instrument that capitalize on the pressure difference created by the change in flow area. Dia punya operating principle ialah the venturimeter consists of converging section, a throat, and diverging section. Dia sama, dia macam orifice juga, cuma dia ada macam ada keleharan, ada leher. Dia ada input tu, dia ada leher, dia output. Okay, so yang bila dia menuju ke tekak tu, ke throat tu, dia converge. Pada tanda keluar, dia diverge. As the fluid enter the converging section, the velocity increase, causing the decrease of pressure. Ni kalau mengikut hukum Bernoulli lah. Okay, and then in the throat, the flow area is smallest, resulting the lowest pressure. As the fluid enter the diverging section, the flow area expand and then it begin to rise. Okay. So inilah dia apa tu, venturi lah. Inilah dia venturi. Dia ada macam ni. Okay. So ni, ini inlet, ini outlet, sini ialah throat, tekak dia. Jadi bila flow masuk sini, ikut apa, kalau berdasarkan hukum Bernoulli, pressure akan jadi rendah, velocity akan jadi tinggi, dan ini bergantung pada area. Dia sama je macam case orifice, cuma ni panggil venturi lah. Alright, so saya teruskan lagi. Ini measurement process. The pressure difference between the throat and the inlet of the venturimeter is measured using pressure sensor. Dia mesti akan guna sensor lah untuk mengukur. The pressure difference is correlated with the flow rate using calibration data or equation. The geometry of the venturimeter help convert the pressure difference into accurate flow rate measurement. Okay. Ini pula flow nozzle. A flow nozzle has similar concept to an orifice plate, but the design is more streamlined. It includes a converging section followed by throat and diverging section. The fluid accelerates as it passes through the converging section, resulting in pressure drop in the throat. And the pressure difference between the upstream and throat is used to calculate the flow. Ni macam ni. Sama je. Daripada area yang besar, big area, and then dia kecilkan jadi area yang kecil, small area. Okay. Sama je. Ni flow nozzle. Alright. Ni dia cerita sikit. Saya rasa ini perkara ni penting untuk awak tahulah. Benda ni penting. Advantages of flow rate measurement instrument. Kelebihan kita menggunakan flow rate measurement punya instrument, dia ada 4 lah. It's a very accurate enough for many industry application. Relatively simple and cost-effective design for basic measurement. Suitable for wide range of fluid types. Some design can handle high flow rates. Maknanya pertama tu dia tepat, dia simple dan sangat cost-effective. Lepas tu sesuai digunakan pelbagai industri yang berkaitan dengan fluid, And then some design can handle high flow rates. Maksudnya dia boleh setengah reka bentuk tu dia boleh handle dengan high flow rates lah. Alright. Ni pula disadvantage dia ialah pressure recovery can be incomplete, leading to energy loss. Dia tak sempat nak recover pressure tu. So akan cepat hilang energy. Lepas tu ketepatan tu dia bergantung juga. Kadang-kadang apa tu kita panggil, ketumpatan tu kan, row tu kan, ketumpatan sesuatu liquid tu dia nak kena bergantungkan berkadar terus pula dengan ketepatan. Itu masalah dia lah. Okay. Dia limited accuracy for low flow rate. Maksudnya kalau flow rate tu rendah, dia tak apa nak tepat pula. Installation and maintenance can be complex for certain design. Okay. Ini piston flow meter. In a piston flow meter, a piston move within chamber as fluid flow through it. The piston movement is proportional to the volume of the fluid passing through meter, and then the flow rate is calculated based on piston displacement. Ni macam ni lah. Ada piston, tahu piston macam mana kan? And then piston tu dalam chamber, bila fluid tu tolak, dia akan menggerakkan piston tu. So sejauh mana piston tu digerakkan, kita dah tahu dah berapa flow rate. Macam ni lah. Bila masuk in, dia akan tolak piston ni, ombuh ni dia akan tolak ke atas dan dia akan turun ke bawah. Jadi displacement ni kita dah tahu dah macam mana. Okey, untuk displacement ni berkala terus dengan flow rate. Alright. Ni pula kita ada pula rotary piston or rotary vane. The as fluid flow, this component rotate. Bila nama rotary piston, jadi piston tu dia berpusing lah. Okay, bila fluid masuk dia akan pusing. Pada time dia pusing, dia rotation tu proportional dengan volume ataupun fluid yang flow through the meter. Jadi angle tu atau radian tu dah akan equivalent to the flow rate. Akan satu fluid. Macam ni. Ni awak nampak ni ada flow direction masuk dalam. So ini pun berpusing. Hasil pusingan ni tu kita dah tahu dah berapa flow rate tu. Ni flow tu akan keluar lah. Sebab masuk mesti akan ada keluar. Okay. Then kita pergi kepada notating disk. Notating disk flow meter use a disk that wobble or nutates within a chamber as fluid flow through, and the disk motion is related to the volume of fluid passing through the meter. The movement of the disk is converted into flow rate. Ni macam ni disk tu. Dan bila in kan, lepas tu flow fluid tu masuk, jadi pergerakan fluid tu akan mengirakan pasal flow rate lah. Okay. Oval gear pun sama. Putaran oval gear tu akan menyebabkan flow rate tu lah akan boleh kita calculate flow rate lah. Ni lah. Ini kalau awak tengok, pusingan gear yang oval tu, bila dia punya pusingan tu akan boleh kita kirakan flow rate tu. Okay. So, selesai flow rate, kita akan ke temperature measurement. Okay, kita sambung lagi ke kelas kita, kuliah akan datang. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Okey, Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Kita sambung lagi kelas kita untuk kita tamatkan kita punya bab 2. Tadi saya dah cerita pasal flow rate, sekarang saya nak cerita pasal temperature ya. Alright. So hari ni kita akan cerita pasal temperature. Ada beberapa karakteristik lah kita nak cerita pasal temperature. Pertamanya, temperature punya unit ada 3 jenis lah biasanya. Celsius, which is degree centigrade. The Celsius scale set 0 degree centigrade as the freezing point of water, and 100 degree centigrade ni for the boiling point lah. Kalau kosong ni freezing point, beku, at standard atmospheric pressure. Okay, and then Fahrenheit degree F lah. The Fahrenheit scale is commonly used in the United States. It's set 32 degree Fahrenheit at the freezing point of water, and then 212 degree Fahrenheit for the boiling point. And then Kelvin. The Kelvin scale is an absolute temperature scale where 0 Kelvin is absolute zero, the critical point where all the molecular part will cease. So here is the principle of heat energy. Biasalah kalau main temperature kita akan main dengan heat energy. The heat energy is the result of the random motion of particle, atom dan molecular. Maksudnya kalau kita panaskan, maka ini hukum Brown kan, bila kita panaskan maka molekul tu akan bergerak secara rawak. Bila dia sejuk, maka molekul tu akan lebih sustain atau expandable lah. Okay. And then the temperature of the object is a measure of the average kinetic energy of this particle when two objects at different temperature comes into contact. Heat energy flow from the hotter sub-object to the colder sub-object until they reach thermal equilibrium. Alright. Inilah sedikit sebanyak principle of heat transfer. Heat transfer ni boleh bergerak melalui 3 perkara ni lah. Ini 3 perkara ni common lah yang kita akan jumpa. This is common. Kita akan deal dengan conduction, convection dan radiation. Conduction ni the heat being transferred to direct contact. Contohnya ini surface panas. Saya pegang surface panas, saya dapat rasa haba daripada surface panas tu, maka perpindahan energi ataupun perpindahan the heat transfer process tu is been going on through conduction punya principle. Convection is more like aircon. Convection kan, kalau aircon dia tembak, kita rasa sejuk walaupun tak ada direct contact. Itu namanya convection. Ada liquid biasanya dia akan transfer ada either by liquids or gases lah. Okay. Ni adalah a bit technical. Warmer fluid rises, displacing cooler fluid, creating a convection current. Radiation ni the heat through electromagnetic wave or radiation. It does not require a medium to travel through. It going to emit or absorb the radiation based on the temperature. Radiation ni biasanya sunlight. LIGHT. Sunlight ni memang heat transfer through radiation lah. Daripada matahari dia transfer, dan dia tidak perlukan medium apa-apa pun. Kalau dia sama macam convection, cuma convection dia perlukan medium. Heat tu dia travel through movement of fluid. Tapi yang ni dia tak perlukan medium. Dia boleh sampai je. Paling dekat sekali ialah radiation ya. Ini sedikit sebanyak thermal expansion. Thermal expansion is a tendency of substance to change their dimension, length, area or volume due to the change in temperature. When heated, apabila dipanaskan, most material expand, and when cool, they contract. Dia akan kecut. This phenomenon is a result of the increased kinetic energy of particle at high temperature. This principle is used in various applications, such as in industrial of expansion joint, in bridges, or functioning in bimetallic strips lah. Bimetallic strip tu yang macam ni. Ni bimetallic strip. So bila dipanaskan dia akan memanjang. Bila sejuk dia akan bergulung balik macam ni. Tu namanya bimetallic strip untuk thermostat. So saya teruskan. Ini adalah expansion thermometer, known as a liquid in glass thermometer. Biasanya dia bekerja secara prinsipnya substance ni apa-apalah, liquid ke apa ke, substance tu akan expand and then contract in change in temperature. Macam thermometer kan kita guna mercury. Thermometer kita guna substance ni mercury. Okay. This thermometer typically consists of glass bulb connected to a narrow capillary tube filled with temperature sensitive liquid such as mercury or alcohol. As temperature increases, the liquid expand and rise to the capillary, allowing the temperature to be read from the scale. Maknanya bila dipanaskan, okay, the liquid tu expand and then naik, dan dekat kapilari tu, dan dekat kapilari tu kita letak ada scale. Kita tahulah berapa temperature tu. Itu ialah prinsip untuk termometer. Contohnya macam ni lah. Okay. Resistant temperature devices. Ni macam perkara baru kan. Okay. RTDs are temperature sensor that rely on the principle of electrical resistance change with temperature. Maksudnya kalau ada sensors ke apa ke yang berbentuk electrical yang resist dengan temperature, maka dia akan memberi sensor dan dia akan memberikan bacaan. They are typically made of materials with predictable and repeatable resistance. Ini maksudnya reading dia consistent. Okay. As temperature changes, the electrical resistance of the RTD changes in a known and linear manner. This change in resistance can be measured and converted into accurate temperature reading. Macam ni lah, macam prop lah lebih kurang. Letak dekat tempat panas, dan dia akan memberi bacaan. Dia akan haba tu akan resist dengan elektrik, dan elektrik tu akan memberi bacaan pada sensor, dan awak dapat bacaan lah. Okay, ni lebih kurang macam prop lah. Okay. Thermistor is another type of temperature sensitive resistor. Tapi beza sikit dengan RTD ialah thermistor ni dia highly nonlinear relationship with resistance and temperature. Made of ceramic material lah with very high temperature sensitivity. Thermistor can be classified into two main types. Dia ada dua jenis. Dia ada dua jenis. Satu negative temperature coefficient, which exhibit decreasing resistance with increasing temperature to show increased resistance with rising temperature. Thermistor are commonly used in application where their nonlinear character can be exploited for specific temperature measurement requirements. Ni bit thermistor dah kan, tak tahu kan. Thermistor kita ada buat untuk wiring. So ni thermocouple are temperature sensors that operate based on Seebeck effect, which involve the generation of voltage across the junction with different metals. When there is temperature differences between the junction and other ends of the metal. Different combination of metal are used to create various type of thermocouple suitable for specific temperature range and application lah. Sama je tepuk thermocouple ni. Okay. Pyrometer ni dia pula dia infrared tau. Dia macam ni lah. Macam COVID tu. Dia akan tembak laser sini lah, dan dia akan bagi bacaan lah. Perbezaan apa yang sensor ni baca, nanti dia akan beri bacaan. Okey, liquid inglas thermometer ni sama je. Dia rasanya dia punya fungsi sama dia macam standard thermometer. Bimetric thermometer pun sama. Bila panaskan dia akan mengembang, bila sejuk dia akan mengecut. Field system thermometer pun sama. Dia guna temperature sensitive fluid to transmit thermal expansion or contraction to a pointer or indicating device. Okey. Tak banyak beza, awak boleh baca je. Inilah dia, liquid inglas thermometer sama je. Ini kata bimetric bila dipanas, ini katalah dipanaskan, ini akan expand. Bila dia akan expand, maka dia akan adalah mechanical device kat sini macam mana ke yang akan menyebabkan bacaan ke kiri atau ke kanan. Okey. Sama juga macam ni. Feedback effect ni ialah keadaan di mana feedback effect ni ialah thermocouple consists of two different type of metal wire referred as a leg of thermocouple. These two legs are joined together at one end, kita measurement junction. Feedback effect lah. Ni dia boleh baca lah, ni tak adalah apa sangat pun. Thomson effect. Ini pun tak ada apa sangat. So selesai ya untuk bab 2.